Introduction to thermochemistry. Changes in matter involve changes in the energy content of matter. Thermochemistry is the study of energy changes involved in physical, chemical, and nuclear changes of matter. This is sometimes also referred to as the study of the heat changes of matter. Heat and energy are used interchangeably in this area of chemistry. So sometimes a textbook might say heat, sometimes it'll say energy, but it means the same thing. The first law of thermodynamics states that energy in the universe is conserved. It's neither created nor destroyed. So we're going to use this concept in this unit. So if this box represents the universe, so this is the boundary, that's the universe, we are interested in two parts of the universe. We have something called the system, and the system is whatever we're studying. It's the part that we're interested in. It could be a reaction in a nuclear reactor, it could be a reaction in a beaker, it could be a reaction in a calorimeter or the melting of an ice cube on your hand. Whatever we're studying, that's the system. Everything else in the universe is considered the surroundings. What we're going to consider the surroundings in this unit is basically just the part of the surroundings that actually interact with the system. So the surroundings interact with the system. So we're going to be looking at more localized than rather the edges of the universe. And what's going to happen between the system and surroundings is there could be an exchange of matter and energy. So we're going to look at the interactions between the system and the surroundings. Now there's three types of systems we're going to look at. So there's three types of systems: an open system, a closed system, and an isolated system. An open system can exchange energy and matter with the surroundings. So this is like a reaction in a beaker and a gas is formed. So the matter is the gas escaping to the room, and the energy could be the change in temperature. A closed system only exchanges energy with the surroundings. An isolated system exchanges neither energy or matter with the surroundings. And scientists agree it's pretty hard to actually make an isolated system on Earth, but that's the idea. Energy. Energy is either kinetic energy, the energy of movement, or it's potential energy, and this is stored energy. Now, how it's stored depends on the condition. You can have potential energy due to the placement of an object. It could be the height of an object, or it could be stored energy in bonds. It has the potential to do some work. The total kinetic energy of a system, though, which we call thermal energy, cannot be measured. But we can measure the average kinetic energy, and this is called the temperature. So if we take the temperature at any given of a system at any given time, we are measuring the average kinetic energy of the particles. If we measure the temperature then before and after a change, a chemical change or a physical change, it'll give us an indication of the heat or energy change of the system. So back to our universe in a box. So we've got our system and we've got our surroundings. So most of the time we're going to be looking at closed systems. We're going to be looking at energy. This is what we can measure, the average kinetic energy of the particles. So the system can absorb energy from the surroundings, or it can release energy into the surroundings. So if we measure the temperature change in the surroundings, we'll know whether or not the system absorbed or released energy. So we're going to take the temperature of the surroundings. So we're going to look at delta T, which is the final temperature minus the initial temperature. So if the temperature change is positive, that means the final temperature was larger than the initial temperature, so heat was released by the system. If we have a negative delta T, that means that the initial temperature was higher than the final temperature, which means the surroundings got colder, which means heat was absorbed by the system. Now, if a system absorbs heat, the system is said to be endothermic. Takes energy in. If the system releases energy or releases heat, it is said to be exothermic. Releases heat and the temperature of the surroundings will increase. So the energy of the universe is constant according to the first law of thermodynamics. So that means the change in energy of the universe is zero. But the total energy of the universe is the sum of the energy of the system and the surroundings. So it's the sum of the energies of the system and the surroundings. So therefore, a change in the energy in the universe is equal to the change in the energy of the system plus the change in energy of the surroundings. But if the change in the universe is zero, By rearranging this, we can see that the change in the energy of the system is equal to and opposite of the total energy change in the surroundings. So what this means is the quantity, the value, the number associated with the energy change is the same, but the sign is opposite, because if energy is released to the system, that means the surroundings absorbed it. This concept is going to be key to solving some of our mathematical problems in this unit. So this is a mathematical equation that helps you calculate the amount of heat absorbed or released during a reaction or a change. So Q is heat, M is mass, this is measured in grams, delta T is the change in temperature, and it's measured in degrees Celsius, and it's always T final minus T initial. And C is called the specific heat capacity. And this is unique to every type of material. And basically what it is the amount of energy in joules to raise the temperature of of 1 gram of a substance (1 degree Celsius). Amount of energy to raise the temperature of 1 gram of a substance by 1 degree Celsius. So the units are joules per gram degrees Celsius. Because we can measure the temperature of our surroundings, this is the mathematical equation used in reference to the surroundings, where M is the mass of our surroundings, not the system, just the surroundings. So the change in temperature of the surroundings, the specific heat capacity of the surroundings, and the mass of the surroundings. So in terms of our system, we have something called enthalpy, or H. And this refers to the energy of the system. The true definition is the energy of the system plus the change in pressure in volume. But because we're dealing with situations where we have basically liquids and solids, we can say that this really doesn't change, so it's equal to 0. So when we're talking enthalpy, we're talking about the energy of their system. But because we can't measure the energy of the system, the thermal energy of the system, we measure the change in energy. So we're measuring the energy before, and we're measuring the energy after our change. Now, because if a system releases energy, the surroundings absorb that energy, there's a relationship between the enthalpy change of the system and the heat change of the surroundings. So if we can measure the temperature changing our surroundings, we will be able to figure out the energy change of our system based on this mathematical relationship. And we'll get into that in further detail shortly.